Okay, what we're going to do here is before I gave you a log or a logarithm and you had to expand it, now we're going to do the opposite. I'm going to give you one and you're going to have to compress it, if you will, or write it as a single logarithm. Okay, so write the expression as a single logarithm. So we're just going to start over again at number 1. So if I give you this, we'll start off easy. What if I give you the log of x plus the log of y? Log of x plus the log of y. Who has an answer for me? Let me see, someone I haven't heard from. Rachel.
Log of x.
Very good. The log of x times y. Nicely done. All right, we'll keep it easy still. All right, let's try another one. What about the natural log of y minus the natural log of 3? Natural log of y minus the natural log of 3. Who wants to give this one a shot? Anyone? Anyone? Anyone I haven't heard from? Yes, Cassie.
The natural log of y divided by 3.
Very good. The natural log of y divided by 3. Nicely done. Okay, and still kind of in the easy zone. Let's try this one. What about 1/3 times the log of x? What about 1/3 times the log of x? Who wants to give this one a shot? Let me see. Anyone I haven't heard? Alex?
Log of x to the 1/3.
Very good. The log of x to the 1/3. These are all our answers. We are mathematical superstars. Oh, did I mess something up? Everyone's hand is going up right now, and I'm definitely a little self-conscious. Okay, what's the problem?
Log to the 3rd root of x.
Oh, yes. I'm sorry. If you want to, I'm like, oh my god. Like, okay, yes. If you want to write this as.
I started getting really self-conscious too because I thought my answer was wrong.
No, I know, but it was just like you don't understand. Being me up here, it was like boom, like everyone's hand went up, and I'm like, oh god, this is on video. I'm going to edit this out. Like, okay, yes, you could write it that way if you so desire. Okay. All right. Let's try and make it a little more difficult. All right, let's try number 4 right here. I'm sorry that I'm going so close, but I have a really fun, nasty one that's going to take a lot of room, so I need to keep this as close as possible. All right, what about this? 2 times the natural log of x plus 3 times the natural log of y. Yes?
The natural log of x squared y cubed.
Okay, so you're saying it is the natural log of x squared y cubed. Yes. Natural log of x squared y cubed. Very good. All right, what about this one? Because you guys are so smart. Let's try this one. 4 times the log of xy minus 3 times the log of yz. Try that one. Yes, what you got for me?
Log of xy in parentheses to the 4th.
Log of x, y in parentheses to the 4th. Yeah?
Divided by yz in parentheses to the 3rd.
Very good. Okay, because basically, remember before how we were bringing it down? Now we're going to do the same, and we're going to bring it up. Okay? Now we're do the same, we're going to bring it up. Yes?
Could you simplify and like distribute the exponents so then it's x to the 4th y to the 4th over y to the 3rd, z to the 3rd, and then cancel out the y?
Oh, I see what you're saying. That was an accident on my part, but absolutely. You know what? That's a very good point. We should probably then do here, that's great, the log of x to the 4th, y to the 4th over y to the 3rd, z to the 3rd, which will then become, because you see you have 3 here, that'll go to 1, so it'll be the log of x to the 4th y over z to the 3rd. That was good. Nicely done. Very good. I meant to not have them be the same variable, so good job, so that couldn't happen. But that illustrates a great point that if that does happen, yeah, technically if you gave it to me in this form, I'd mark it wrong because it's not completely reduced. Everybody understand? So nicely done. All right, let's try another one. I'm going to come over here because I want this big space for 1. So let's do number 6. This one's a little long too. 3 log x, this tests if you know what I'm talking about. 3 log x minus log y minus log z plus 2 log s. So try to write that as a single log. Try to write that as a single log. Okay, does somebody have an answer? Does somebody want to give it a shot? Let me see, is there someone, I see a couple hands up from people I've heard from. Does anybody that's never given me an answer want to give it a shot? No? Okay, we'll go to Grace, because I've only heard from you once, but I've heard from Rachel twice, because she chimed in on that last one. So what do you think?
Log x to the 3rd, s to the 2nd over y z.
Log x to the 3rd, s to the 2nd over y z. Okay. Who agrees? Raise your hand if you agree. Raise your hand if you disagree. Okay, good. Everybody agrees or didn't participate in the vote. That is correct. That is correct. So, remember what I said. Anytime there's a minus in front, boom, you know that's in the denominator. Boom, you know that's in the denominator. Anything with a plus in front, that's in, right here in the numerator. And this, because it's a plus in front, is in the numerator, even though there's not an actual plus, because it's the first term. Okay? Very good. All right, who's ready for the wicked fun one?
Yeah.
Yes. Okay. All right, here we go. Number 7. Have fun with this one. The log of A minus 2 log B plus 3 log C minus 5 log D plus 7 log E. Now, let me put it to you this way. If you can successfully do this problem, you understand this. Because I can't really make it any more difficult other than just tacking on more to see if you get the concept. Okay, so let's give you some. Okay, who's ready? Who wants to give an attempt? Hannah? All right, let's see what you got.
Log A times c to the 3rd times e to the 7th. Over
Okay, wait, hang on 1 second. Sorry. Log A times what?
c to the 3rd
Yep.
times e to the 7th over d squared times d to the 5th.
E squared times d to the 5th. All right, let's get full classroom participation. Who agrees? Who disagrees? Okay, that was about 85% participation. Nicely done. Yes, Hannah, that is correct. Nicely done. All right, so who is like, their confidence in math just like went to here right now. They're like, yeah, I can take on the world. Okay, good. Good, because we're probably going to stop here. So everybody feeling good? All right, good.